So I'm going to show you the last topic that we have to cover for the semester. And it's a conversion between moles and particles or atoms, grams. It's just converting units. So let's start off with our first problem that we have here. The first problem we have here is to ask how many particles are in 2.3 moles of oxygen. So we're going to start the same way every single time. And the first thing that we're going to do is we're going to start by writing down what we were given in the problem. We were given 2.3 moles of oxygen, so that'll be O2. Next, we are going to take and we're going to draw an arrow to what we are looking for. We are looking for X particles of oxygen. Right? So this is how that setup should always be. On the left-hand side of the arrow should always be the given. The right-hand side should be the unknown. We're then going to take the units that we have in the problem. So the moles, O2, and then the particles, of O2. Right? So we're going to bring our units down. It's super important that we include units because units is going to tell us what are the conversion factors that we need to put down here in the bottom. So we need to figure out what numbers go down here in the bottom, and that all depends on the units that we have. So if we are looking at moles, anytime they give you moles in the bottom, the unit that we're going to use, or the conversion factor we're going to use, is 1. And then if they give us particles, particles will always be equal to Avogadro's number, or that's 6.02 times 10 to the power of 23. Because as you saw in our notes, 1 mole is equal to 6.02 times 10 to the power of 23. This is where we get the 1 and the 6.02 times 10 to the power of 23. Now that we have the blanks filled in, all we have to do is our butterfly method. We're going to cross multiply and divide. So in our calculators, we will put 2.3 times 6.02, the second, or the blue button, e to the 23. Or you can just put 6.02 times 10 to the power of 23. We're going to hit enter, and then hit divide by 1, and we will get our answer. And the answer is going to end up being 1.38 times 10 to the power of 24 particles of O2. That's how we solve it. Let's do 2 more. This one wants to know how many grams are in 3.8 times 10 to the 26 atoms of sodium. So again, always start off by writing down your given. You're given 3.8 times 10 to the power of 26 atoms of sodium. Always, always, always include your units, guys. Draw an arrow to what we're looking for. We are looking for X grams of sodium. Okay. We have our given and we have our unknown. Now all we need to do is we need to drop the units down. So atoms of sodium. And we have grams of sodium. Now we need to fill in our blanks using the units. So if it says atoms, so last question it said particles, but if it says particles, atoms, molecules, or like formula units, those will be the 4 that you may see. That means you need to use Avogadro's number. That's 6.02 times 10 to the power of 23. If it says grams, grams means that you're looking for the molar mass. So you need to go to the periodic table to find that. Since it is just sodium, you're going to look at the periodic table. You're going to find the mass of sodium, and it's going to be 22.990. If it was a mass of, let's just say, water, H2O, you have to go to the periodic table and find the molar mass of H2O. So 2 times the mass of hydrogen plus the mass of oxygen. So that's just a little review from what we did a couple days ago. Now we have our blanks filled in. So all we need to do is we need to butterfly it, right, and plug it into our calculators. So 3.8 times 10 to the power of 26 times 22.990, enter, divided by 6.02 times 10 to the power of 23, enter. And then it should give you your answer. You should get 1,400 or 14,511.96 grams of sodium. And we'll do one more. Right. Last one. I want to know how many moles are in 4.55 grams of carbon. So again, start out by writing down what they give you in the problem. They give me 4.55 grams of carbon. We'll draw an arrow to what we're looking for. We are looking for X moles of carbon. Next, we're going to bring the units down. Now we need to fill in the blanks by using our units. So if it is grams, again, you're looking for the molar mass of the element or compound. So you'll go to your periodic table to find that. You go to the periodic table to find carbon, and you'll see its mass is 12.011. Then we take a look on the other side, and we see that we are looking at moles. Moles is always going to be 1. We have our blanks filled in, so all we need to do is cross multiply and divide. So 4.55 times 1 divided by 12.011. We're rounding to 3 decimal places here. So 0.379 moles of carbon. And that is it. So before we end, I am going to give you a quick little equation. I guess you could say that you're going to plug stuff in. So it should always be your given going to your unknown, okay, and then you will have some kind of units, right, depending on what your given is, going to some kind of unit of unknown. Let's do that, unknown. And units of your given. Okay. So, in order to figure out these numbers right here, okay, in order to figure out those numbers, you must look at the units, right? Looking at the units. And if the unit is grams, you're going to go and find the molar mass from the periodic table. If the units is moles, it is always going to be 1. And if the units is atoms, particles, molecules, it's going to be equal to 6.02 times 10 to the power of 23. This is how you find the units that go in the blanks where the yellow circles are. That is the only numbers that you should ever put in the yellow blanks. Okay, do not use the numbers from the given or the unknown, right? And that's how we do unit conversions, guys.